Let's answer the question in part A. That is, we will determine the equation to model f of t. So for this, I'm going to use this initial conditions. That is, the initial temperature of the coffee is 100 degrees centigrade, which means at t equal to 0, f of t equals 100. So we plug this into this equation. So therefore, this becomes 100 equals T naught is the room temperature. So we can replace T naught by 20 plus C e raised to the power of negative K times of T equal to 0. So therefore, this becomes 0. So we can determine C from this equation, that is 100 equals 20 plus C times of e raised to the power of 0 is 1. So this becomes C. So we determine the value of C as 100 minus 20, which is 80. Therefore, we plug this value of C into this equation, as plus we replace the T naught by 20. So therefore, we get the model as f of t equals T naught is the room temperature, that is 20, plus C equals 80 e raised to the power of negative kT. We can find the value of K using the condition. The coffee cools to 60 degrees centigrade after 1 hour, which means at T equal to 1, the f of t equals 60. So let's plug this information into this equation. And when we do that, we get 60 equals 20 plus 80 times of e raised to the power of negative k times of t equal to 1. So I replace t by 1. We can solve for k from this equation. First, I subtract 20 from both sides. Then I will get 40 equals 80 e raised to the power of negative k. Now I divide both sides by 80, so therefore it becomes 40 over 80 equals e raised to the power of negative k. So 40 over 80 is half. We can do the cancellation. And so this equation becomes half equals e raised to the power of negative k. To determine the value of k, we apply the natural logarithm to both sides. So therefore this becomes natural logarithm of half equals natural logarithm of e raised to the power of negative k. And using the properties of logarithm, this negative k comes in front. So therefore, this becomes negative k times of natural logarithm of e. We know the natural logarithm of e equal to 1. So in fact, we can remove this from the equation. So this right side basically becomes negative k. And on the left side, we have natural logarithm of half. So we have to now divide by negative 1 to determine the value of k. So therefore, this implies k equals natural logarithm of half divided by minus 1. And when we plug this into the calculator, we get the value of k equal to 0.69314. So this I have rounded to 5 decimal places. So we can now plug this value of k into our model, that is into this equation. So therefore, the model for f of t equals 20 plus 80 times of e raised to the power of, maybe we can just clear this some space, e raised to the power of negative of 0.69314 times of t. So this is the model for the f of t, that is the temperature of the coffee after 10 minutes, where t is in hours. We now answer part B, that is, we have to determine the temperature of the coffee after half an hour. So this means we will utilize the model which we have found in the part A, and we have to just replace t equal to 1 by 2 into this model. So let's do that. So therefore this becomes f of 1 by 2 equals 20 plus 80 times of e raised to the power of negative of 0.69314 multiplied by half. So we can plug this into the calculator, and when we do that, we get the value as approximately 76.57 degrees centigrade. So this is the temperature of the coffee after half an hour. We will now determine the time it takes for the coffee to cool to 50 degrees centigrade. So this basically means that we have to replace f of t by 50 and solve for t in this equation. So let me do that. I replace f of t by 50. This equals 50 equals 20 plus 80 times of e raised to the power of negative 0.69314 times t. That is, we keep the t as it is. Now we have to solve for t from this equation. So first I subtract 20 from both sides. So then I get 30 equals 80 times of e raised to the power of negative 0.69314 t. Now I divide both sides by 80. So therefore this becomes 30 over 80 equals e raised to the power of negative 0.69314 t. We then apply the natural logarithm and solve for t. So this becomes, in fact, this zeros I can cancel. This is basically natural logarithm of 3 over 8 equals natural logarithm of e raised to the power of negative 0.69314 t. Using the properties of logarithm, we know that this comes in front and natural logarithm of e equal to 1. So therefore, finally, we solve for t. This equals natural logarithm of 3 by 8 over this quantity, that is a negative of 0.69314. And we plug this into the calculator. When we do that, we approximately get the value of t equals 1.415, and the t is in hours, so we mention this as hours. In fact, we can calculate this decimal portion, that is 0.15 into minutes. So we can write down the time as a combination of hours and minutes. So we have the whole number part 1. So therefore this is 1 hour, and 0.415 to convert to minutes, we multiply this by 60. So when we do that, we approximately get 25 minutes. So this is approximately 25 minutes. So we write down this as 1 hour and 25 minutes. So that is, after 1 hour and 25 minutes, the temperature of the coffee cools to 50 degrees centigrade. So this answers part C.